Hi everyone, my name is Viraj. I work with Sociomantic Labs Berlin as an Android developer and mobile team lead. And today I want to talk about problems like this. This is Google Play Store application, and if you don't have internet connection and if you rotate the screen, the loading indication stays there. It doesn't end. So this is just one of the example, but there are so many different variety of problems we are facing, but they are of the same type and same segment. So in this presentation, we'll talk about problems like this and how to solve them. So before we jump into the actual topic, I would just like to revamp and give you some introduction on where we are right now, a couple of problems we faced recently, and where we are heading. So the first problem we faced recently was the God activity problem. A couple of years back, it was not that common, and it was quite common to put everything inside the activity. Activity used to do everything: UI stuff, business logic, code transformation, networking. So the problem it caused was it was not testable, it was not modular, and it was not scalable. So to solve this problem, architectures came into picture. Two of the most common architectures are MVP and MVVM because they work really well for Android. So just to give you a quick overview, in MVP we have one-to-one relationship. So a single view has a single presenter and vice versa. But in MVVM we have one-to-many. So a single view may have multiple view models, and a single view model can be used by multiple views. So that's the only difference. Otherwise they do the same thing. So they take all the responsibility from view, they do the hard work and let the view be as dumb as it can. So it solved the God activity problem, but it created another problem, which is God presenter or view model problem. So now the view is doing just the view stuff, but the rest of the stuff is not that small. There are so many responsibilities which are done by presenter or view model based on whatever architecture you chose. So to solve this final problem, clean architecture came into picture, which finally solved the problem. But once we apply a proper clean architecture, the architecture looks something like this. So we have a view and presenter or view model based on whatever your choice of architecture is. And after that, we do some more layering, which is a data source or a repository. And then after that, we may have 3 or less than 3 data source, cache followed by database and networking. So with this kind of architecture, it becomes truly modular and scalable. So for example, right now if you're using library A to do your database stuff, and then you see that, all right, there's a library B which is far more superior and better suits our needs, then you can easily change that particular set of code and you don't have to touch any of the rest of the application. So it became truly modular, and it's super easy to test, because if I'm testing my data source, I can easily mock any of the data, individual data layers. And then if I'm testing my presenter or view model, I can easily mock my data source. So in true sense, it solved the layering, modularity and testing problem. And the reason for me to give you all this quick background was to tell you like where we are right now, because we solved a couple of problems and this is where we are right now. And all the issues which I'm gonna describe about are with the context of this. So this is where we are, and then let's try to jump to the next set of questions. So once you decide that this is going to be your architecture, or if it's already there, then the first question comes to your mind is the lifecycle question. Because if you look at the specific code in the relationship between view, presenter and data source, it looks something like this, wherein the view first says, okay, I came into foreground, do the binding, and then whenever the presenter or view model says, okay, my view is ready, it tells the data source, hey, give me my data for my view. And then view is dying, it will say that, okay, unbind everything, I'm about to die, and then it will do the cleanup. So no matter how many layering we do, view is the one which is still driving everything. Or in other words, view's life cycle is still driving and calling shots for everything. So the question is, when do we do bind and when do we do unbind? Because that's super important. And when I say when, it's like which life cycle call we should do that, which is quite common to do on resume or on start for the bind stuff. And for unbind, it is quite common to use on pause or on stop. It's quite fine and it's quite common, but the moment we do this, it creates another problem, which is view reloading problem. It looks something like this. Let's say there's a user which opens the application, we engage him with a loading indication, and in the background we make a network call from network. But before we get to complete that network call, let's say the view is partially or fully blocked. It can happen from several reasons. There's a pop-up, user presses the overview button or home button. So if any of these actions happens, our network call will get interrupted. Because since our callbacks are driven from view, we'll do all the cleanup because we feel like view is about to die. So that's why the call is interrupted, and it will stay interrupted until the view comes into foreground again. And when that happens, we'll initiate another call, and then when we get the data, we update the view. But if you notice, the number of calls we made is 2. One complete network call and one partial network call. Now it's super bad because in mobile, especially Android, everything is super expensive, especially the data. So we should not be doing all this and wasting users' data in terms of be it network call, database, or anything. So it should be just one network call. Now we can play with different life cycles to solve this problem. Like for example, we can use onCreate and onDestroy to bind and unbind, but it doesn't truly solve anything. It works for a couple of cases, but not all the cases. Because the root cause for this is not just life cycle. The another problem for this is the configuration changes. The configuration changes, it's quite known as orientation change, but it's not just that. I mean, if you just set your orientation to portrait, usually developers think that it's fine, I don't have to deal with config changes, but it's not true. Because there are a couple of other cases like keyboard availability, language changing, docking. If any of these happens, it's considered as a config change, and when that happens, Android will recreate your activity. And when I say recreate the activity, it'll completely destroy the previous instance, it'll create a new one, and it will give you with the updated configuration. So it's quite important that we keep this also in mind when we are talking about lifecycle and configuration. And this problem is even beyond, it's even bigger than the lifecycle problem. Because lifecycle problem we can work with, but this is we can't. Because since the activity is dying, all the callbacks will get called unless you are using retain fragment. So to consider, once we combine these two, it creates these set of problems. View reloading, which we just saw, data interruption, which we just saw. Another one is context leak. So since the previous instance is dying and we are getting a whole new instance of the view, it is super important for us to do the cleanup. If we don't do if we don't do proper cleaning or cleanup on our side, then context leak may happen. So it's really important for us to do that. And finally, a view state management. Now it isn't a thing up until you consider data config changes. So what do I mean by view state management? So there are 3 major segments of view state management. One is view data, state changing action, and one-time action. Now view data is quite common, which we already know. So before configuration change and after configuration change, we want to display the same set of information user was seeing. So if it's a recycler view and if there are 3 elements, we want to display the same thing. So this is not a big brainer. The second one is state changing action. So state changing action is associated with individual elements of your view. For example, a loading indication. So before the configuration change, if the user is seeing a loading indication, we want to display the same loading indication when the configuration change happens. So the elements like this needs to be maintained, and if we don't maintain, we may end up having a view like this. And this is Google Hangout application. If you notice, when I press the floating action button, the state is open, but when I press the overview button and I come back, it doesn't remember where I was. So the states are not maintained in this case. So it's important for us to maintain what's individual state. This is not that damaging, but if you have a saving button or something which can result into an action, and if it was disabled, and if you don't maintain that, it can result into corrupted data. So it's quite important to deal with this kind of problem. The third one I want to talk about is the one-time action. There are a couple of cases, for example, an error message or success notification. We want to display it only once. It is meant for users to consume only once. For example, a snack bar or a toast message, which once we display it once, we don't want to display it again and again because it's already shown to user, it's done. So if you don't handle this properly, you may end up having something like this. This is again Google News and Weather application. If you keep rotating the screen, it will keep displaying the toast message saying updating news. But in fact, it's done updating. but it's not because they haven't handled the one-time action, so it just keeps popping up. So in a couple of cases it's just annoying, but in a couple of cases it may result into corrupt data or corrupt states. So this is just the overview of the problem, just to give you the summary of the set of problems we are dealing with. So the root cause are these two: lifecycle is constantly changing and configuration is constantly changing. And when these two, either of these or both of them happens at once, it may lead to a view rolling problem, data may get interrupted, context leak, and view state management problem. So far I only talked about the problems, like what all variety of problems we are facing, and in the next segment I would like to talk about how we fix them. So let's first see on paper how do we fix this. So if you look at just the architecture of these three elements, what we want to do is, whenever there's a configuration change, we don't want our presenter or view model to die. It needs to be smart enough that if there's a config change, it needs to stay in memory somewhere. We don't care where, but it needs to stay somewhere. And then it needs to be smart enough to differentiate between me dying because of a config change or me dying for good. So when the view is definitely dying, it needs to do the cleanup, and if it's not, it needs to stay in memory. The second thing we want to do is, we don't want our data source to interrupt our networking or any data call if there's a configuration change. So if the view is definitely going to come back, we don't want to interrupt our network call. But if it is dying for good, then we need to clean up. And final and most important thing is, whenever a view comes into foreground, we need to provide him appropriate data with appropriate call state. So view state needs to be maintained. So we need to do three things. How do we do that? There are a couple of solutions. Up until this year, the only solution possible was RxJava's subject-based solution. So we used to divide application into two parts, view and data part. So the view part, even if it is dying, data part used to stay. It was quite complicated, and there was a lot of boilerplate code. It was not that easy to test either. But then this year's Google I/O, Android architecture components were introduced. It's a set of 5 different libraries: Lifecycle, ViewModel, LightData, Room, and Paging library. Paging library is useful when you have to gradually load data for your view. Let's say there's a recycler view, user goes down at the end and you need more data, you eventually fetch, engage user, and update the view. It's useful for that. Room is of course the new database library. I'll not get into any of the detail for these two because we have a presentation tomorrow on Room, so I guess you can join that for additional detail. What I want to talk about is the top 3 libraries. So before I jump into actual definition and what they are, let's look at how individual libraries fit into our existing diagram. So this is the full picture, the Android architecture components. So from top to bottom, if you see, it's the same architecture, the MVVM plus clean architecture. So we have our view, which can be activity or fragment, followed by we have a view model, which internally provides multiple set of live data, followed by a repository layer, which either talks to database or network, depending on whether the data is present in database or not. Now, we'll talk about the top layer, because the bottom layer is not relevant to solve all the problems we discussed. Now, there are 3 things we'll talk about. There's one library, which is Lifecycle, which is used by the views. The ViewModel library, which is used by the ViewModel, and finally the LightData, which is used by the LightData, or which can be used by ViewModel, or it can be a standalone thing. So let's look into detail of individual library, what they are meant for, how to use them, and how they solve the problems we discussed. So the first is Lifecycle. In Lifecycle, it's super simple. It just provides a sophisticated way of dealing with the view state. So it has a couple of states. The most important events are on create, start, and resume, and followed by pause, stop, and destroy. So as we know that Android activity and especially fragment lifecycles are quite complicated, and they can become scary and problematic if you don't know how to deal with them. So that's why they have they defined it into state and not into actual events. So there are only 3 things which are important. Either the view is on resume or on started state, or it is dying. There are only two states which are important. Other states doesn't make any sense from the presenter or ViewModel point of view. So the library, what it does is it just provides the simplified life cycle. So nothing else. It's super simple. Now, this is this is super important because this is the base of Android architecture component. It wants to say that all the views needs to be lifecycle aware, and they needs to provide the appropriate life cycles. How do we use that into two different libraries? For that, we need to use the ViewModel library, which is, like the name suggests, it allows you to create ViewModel. That's it. But it's not that straightforward. It's way more powerful than that. And if you're interested into the source code, if you open the source code of the ViewModel library, internally it's a retained fragment storage. So the way it works is, internally they have a UI-less fragment. Internally they have this set return instance equal to true. So that is how it survives through the configuration changes. And it also acts as a storage. So for example, for my view, if I come for the first time, if there is no view model, it creates the first instance. And next time onwards, it doesn't create a new instance. It gives me the same one from the factory. So this is how it allows your view model to survive through the config changes. And it solves problem number one. Second, it is also lifecycle aware. So it knows what my view is doing. So if it is in proper view state, then it gives the proper data. And if it is dying, it does the cleanup. And for cleanup, it uses the classic onDestroy callback. And whenever there's a callback on onDestroy, it cleanups itself. And it also provides you a provision to do cleanup for yourself using onCleared callback. So there's a callback. So if, for example, if you are having your own implementation for which you want to do cleanup, you can do using this callback. Of course, we'll see everything in code just to give you the overview right now. And the third library, which is LightData. LightData, you can think of it as a sophisticated hot observables. So just like hot observables of RxJava, they are up to date. They don't care if someone is subscribed or not. They do their job and they keep the data alive. So they are similar to that, and they are containers. So you can create live data of any type. It can be native variables like integer, string, or list, or your custom variable. Doesn't matter. It can work with any of the data types you have. And it's lifecycle aware. As I mentioned, everything runs around the lifecycle. So all the components in Android architecture component relies on lifecycle. They also are sophisticated because they know if the view is on started or resume, only then they provide the data. So if the view is not ready, or if it's not viewed by user, then it doesn't update the view. And when the user comes to the state, then it updates the view. So if you have multiple views relying on the same view model, you don't have to worry about what state they are. It's already done inherently by the view model, by the live data. And finally, it also does the cleanup on its own using the onDestroy cleanup call. So finally, to give you the core concept, just a revision, it works something like this. The view is like this. These are my life cycles. I'm interested in services provided by ViewModel or live data. And I don't care about what you do. You do your cleanup. I'm not going to babysit you anymore. These are my life cycle. You keep an eye on them. You do your cleanup. You provide me appropriate data. I'm done dealing with you guys. So there's a clear separation, and they don't want to deal with them. So this is the clear message, and this is the core principle of AAC. So since this is the core principle of AAC, it doesn't work with MVP. And this is the big gotcha. Why it doesn't work with MVP? Because if you see, there's a one-to-one relationship. So that's why it is important, because the idea is that view doesn't have to deal with presenter, but that's not true. The core principle of MVP is that view have to tell presenter when to bind and when to unbind. It needs to provide the context. It needs to say when to leave the context alone. But that cannot happen in MVP. So that's why AAC doesn't completely work with MVP. It works perfectly fine with MVVM, and that is why even the library is called ViewModel and not presenter. They could have easily called it a smart factory, because it doesn't actually do anything related to ViewModel. It's just a factory. But since it works with MVVM, that's why they call it ViewModel. And that's why it's recommended officially that you use MVVM and not MVP. So that leads to the next question. Should you use the view model for MVP? So like, can you use a presenter which extends a view model? Well, no, technically no, because anything beyond your presenter will be a clean implementation of our Android architectures, but not this layer. It will still be a hack, and it wouldn't be fulfilling the core principle of AAC. So that is why it doesn't perfectly work. I mean, it's a hack, but if you're not looking into that, then it works for you. So the second question is, can you use? Well, yes, you can. What will happen is, if you don't want to spend another additional time converting your MVP base code to MVVM, then you can still go ahead and use AAC libraries, because they still work from presenter onwards, not from the view onwards. So that's the core difference between if the AAC works on MVP or not. So you can still go ahead and use it, and eventually maybe if you can, move to MVVM and it will become completely clean. But if you have to, yes, you can. So we talked about different problems and how to solve them, except the one thing which I haven't mentioned yet, which is how do you handle with the one-time action. So for that, they also there's a sub version of LightData which is called single live event. It works something like this. So from your view, when you observe, it provides you the event to observe. For example, it says there is an error. So initially, the M pending will become true. It's a Boolean variable, and initially it's true. So which means it's not consumed yet. And whenever the view has successfully consumed and displayed to user, it becomes false. So the view's responsibility is to tell it to say, okay, I'm done consuming this, and now you can end this event. So this is how it works. It's same thing as live data, but it's meant for one-time use. So that's why it's called single live event. So far we just talked about the theory and concepts and principles. Now let's jump to the code. So if you have an activity, again, I'll use Kotlin syntax, but it's super intuitive. If you have any other question and you're looking forward to Java examples, we also have Java example after this. So I have an activity which extends a lifecycle activity, and that's it. Like just one line. Once you extend it, you are done. Your life cycle is your activity is already providing the life cycle. So step number 1 is already done. The step number 2 would be to create a factory in case you have a view model which requires additional dependencies, and then you create a view model which is late in it. So I'll just initialize now. And on create, you simply say, hey, you ask your factory by giving your context that for this context, for my life cycle, I want a view model of type this, and that's it. What it will do internally is, it will first check if this is the first time or not. If it's the first time, it creates a view model instance and it stores in the factory. And if it's the second time, because of a configuration change, if you come back, it checks in, it already finds the instance, and it gives you the instance. So it's sorted out just by 2 lines of code. And by this, we solve the survival problem, and we solve the storage problem. And finally, you simply say your view model, give me my live data, which I want to observe on with this context. When I say context, it's not actually a context. It's the life cycle events which it's interested in. And then you observe. So within this block, you get the data, and you can update your view the way you want. And that's it. There's no other callback. There is no on start, there's no on stop, there's no cleanup. There's no babysitting on the view side. It's just get me the view model. I'm observing on this live data. That's it, 2 steps. So view side, it's completely clean. And if you, for example, if you're not interested in using activity, for some reason you have fragments, the only difference is life cycle fragment. That's it. So your implementation across different views looks exactly the same, if it's activity or fragment. So it's completely synchronous across variety of views, and you don't have to have different implementation. The second one is the view model factory, which we just used. You just provide this one method called the provider, and within the provider, you just tell how to create an instance of your view model. If you have an additional dependency, you just inject them. It works perfectly fine with Dagger if you may want to use that. And that's it. So this is the only thing you want to provide, nothing else. And how ViewModel and LightData look, it looks something like this. So my ViewModel is extending the ViewModel. The moment I do that, I already have access to all the factories and smart solutions and smart cleanup by just extending that. I don't have to do anything else. Internally, I'm also creating a data subject. It's RxJava's for RxJava. Now it's just a composite disposable for storing my subscriptions. And the second one I have to create is the view state. This also works as a model. It gives you the data and the individual states you may need. And the second one, if you know, it's the live data. So first you need to create the variable and create the appropriate live data. So the live data is of type my model. And that's it. This one line will create the smart live data which my view can easily subscribe and observe, and it doesn't have to do the data polling on that. And in it, I do the first time call for get data. And in get data, I first talk to my data source and ask it for the data. And once I receive the data, I'll update on top of my existing live data. So first thing I do is I change the copy of the data I have right now, and then I post it on top of my live data. And the moment I do that, it will internally get updated on my view side. I'll get a call on observe only if it is on started or on resume. If it's not, there's no need to worry about context leaking or view being null. It's already taken care by the live data. And that's it. So just 3 lines of code will make sure that all your context leak problems are handled. Your view state management is already done here. And finally, I'll get, whenever the view is dying for good, I'll get a callback called on cleared, which I'm overriding. And there I do the disposal of my subscription, which I did for my data source. So it survives through the configuration changes. It provides the latest data, and it automatically does the cleanup on its own. And that's how we solve that. So to summarize all of this, we have these many problems because of lifecycle and configuration changes, and we can solve them using MVVM, clean architecture, and Android architecture components. Thank you very much.